Good day, students. How are you doing? This is me again, Sir Nivero, and welcome to our YouTube channel. So, for this day, we're going to talk about direct variations and perhaps we focus on how to identify a direct variation given an equation, a table of values, and um, graph. Right. So let's start. So objective for today is to learn how to identify, right, and to graph and an equation of direct variation. So vocabulary, direct variation, and constant of variation. So the definition of a direct variation is a linear relationship between two variables that can be written in the form y equal to kx or k equal to y over x. Remember that k must not be equal to 0. The fixed number k is what we call the constant of variation. So you can read direct variation as y varies directly as x, y is directly proportional to x, or y varies with x. Okay, those are just the common one. Right, so let's go ahead to examples. First is how to identify if an equation is a direct variation. So tell whether each equation represents a direct variation. If so, identify the constant of variation. So just remember the formula for the direct variation: y equal to kx or k equal to y over x. Right, so the given is y plus 8 equal to x. Question, is it a direct variation? We'll see. Y plus 8 equal to x. Solve the equation for y, subtract 8 from both sides, so that becomes y equal to x minus 8. Take note, this one is not a direct variation, right? Because for the reason of what? Yeah, this one it's not in y equal to kx form, right? It's not a direct variation. Let's go to the second example. Tell 3y equal to 2x. Now let's make it to solve the equation for y. Divide both sides by 3. So 3y equal to 2x divided by 3. So y equal to 2/3 x. Meaning to say this is a direct variation because it is now written in the form of y equal to kx, which has the constant of 2/3. Next, we can already tell that this is not a direct variation for the reason na y plus 3 is equal to 3x, and yeah, it's not in this form, right? It's not a direct variation, right? This one, it is a direct variation. You just have to divide 4 on both sides, and then yeah, the constant of variation is 3/4 x, right? 3/4, sorry. So this is a direct variation because it can be written in the form y equal to kx. Alright. Now, what about if the given is the table? Tell whether each set of data represents a direct variation. If so, identify the constant of variation and then write the direct variation equation. So now, let's see. Find y over x for each ordered pair. We need to say that is how we find the constant. Right? So the price C cost or weight 69.99, then 234. So y here is actually 2 over 69 and 3 over 99, 4 over 129. So k is not the same. Why? Yes, the constant of a direct variation given the table of values should be the same, but in this case it is not the same. Meaning to say this is not a direct variation. Alright? Remember the formula for the constant, we divide the y by x. So in a direct variation where k is positive, when x increases, y also increases. And also with when x decreases, y also decreases. So next example, we have inches 125, and then centimeters 2.54, 5.04, 12.17. Now let's check if this is a direct variation. Find y over x. So 2.54 divided by 1, 5.08 divided by 2 and 12.7 divided by 5. All these all the results are the same, meaning to say the constant of variation are the same. Therefore, the data represents the direct variation, where k is 2.54. The equation is y equal to 2.54x. Remember the equation for the direct variation, y equal to kx. You just have to replace whatever the value of k to get the equation, to write the equation. Okay. Next, 5, 10, 15 for the price and the weight in pounds. 2, 3, 4. We divide. Are they the same? No, they're not. Right? So if they're not the same, then it's not a direct variation. Now let's try 3 meters in miles. 3, 4, 5, 9, 12, 15. Let's try 9 over 3, 12 over 4, okay, 15 over 5. So the results or for the y over x for each ordered pair are the same. So we say this is a direct variation which has the equation of y equal to 3x. Again, you just have to replace the k in the y equal to 3kx, right? Since k here is 3. Next, what about when given the graph of when you are given the graph? So tell whether each graph represents a direct variation. If so, identify the constant of variation and then write the direct variation equation. Now let's start with this graph. So in this graph, we don't know yet what are the indicators for a graph to be a direct variation. So yeah, this graph passes through the origin 0, 0, right? And this is a direct variation for the reason na 0, 0 may pass here sa 0, 0, and the slope of the line is 1 over 2 or 1/2. So therefore k is equal to negative 1/2, considering it is going to the right. Okay, going to the right, I mean to the left. If you're looking at the camera, in my perspective, to the left hand. Alright, let's go. In a direct variation, the slope k represents a constant rate of change if the graph is given, right? So tell whether each graph, again, same thing. If so, identify the constant of variation and write the direct variation equation. So first thing to check is if the graph passed through the origin. So if it did not pass through, then therefore it's not a direct variation. This is not a direct variation. Now let's try. A truck travels at a speed of 55 miles per hour. Write the direct variation equation for the distance y the truck travels in x hours. So, of course, we can really identify, or we can really define, get the relationship or define the relationship between the distance traveled and the speed of the truck, right? Because they are directly, when you go faster, then you can travel a lot of distance, right? Okay, but perhaps here it's referring to the y truck travels the distance and then in hours. Okay, so let's try. Yeah, it's still a direct variation because if you are traveling in a 55 miles per hour constant, meaning to say this one is constant, right? And average, right? So you will really go a very far distance. You will really reach a far distance. Let's proceed. So to get the distance y, this is y and this is your constant, multiplied by your x, number of hours, or h, right? So distance equal to 55 times number of hours. Use the formula y equal to kx times k equal to, we'll just use a dot here for the 55. So y equal to 55 times x, so y equal to 55x. This is now the equation. Truck travels at a speed of 55 miles per hour. Graph the data. Now we'll try to graph this one. We're done actually. This one is pretty basic to you because you've really understand the concept in the graphing of the quadratic function in the last quarter, last quarter, then this one is not that difficult to you now. Okay, considering, I'm not saying all, but we'll just consider, right? So if my x is 0, meaning I did not run, my time is 0, so we just have to multiply that one. Of course it will pass through the origin, so 0 0, and then if I run for 1 hour, how far am I going to reach? Of course it's 55. Okay, 55 kilometers or miles, yes, miles. And then 2 times 2, 55 times 2, that is 110 miles. 2, 110, 1, 55, 0 0. Now let's try to graph those 3 dots. This is quite pretty basic to you because you've already graphed parabola, and this one is just a linear equation or linear line. So let's try to graph. Right, so we'll start with 0 0 and 155 and 2 110. 0 0 is there. 1, this is 1, and then 55, 55 is somewhere here, yes, somewhere here. And 2, actually, where's 2 is 110, it's somewhere here. It's not actually aligned with 110, but perhaps it's somewhere here, and also 55. So if you connect that, there's your graph of the problem. Okay, you connect the dots, label the axis. That's a graph already. Okay, now y equal to 55x is in slope intercept form with m equal to 55 and the b is equal to 0. The graph shows a slope of 55 and y-intercept of 0. You need to say the graph passes through the origin. Okay? So, yes. How long does it take to travel 660 miles? Find the value of x when y is equal to 660. So, we're just going to replace the y here by 660. And then, yeah, solve for x because it's asking for the time, how long. Okay, so we divide that, and then the result is 12 hours. It will take 12 hours to travel 660 miles. Okay, so I think we'll just stop right here, and thank you for watching. Thank you, and get